My name is Marcin, one of the founders of Snowflake, and I'm here to tell you a bit about Snowflake. It's a very short presentation, and I'm a bit late, so I'll try to stick to the time. First, we are a small, young company, so maybe I'll introduce us a bit. We're roughly 4 years old, and we were founded in 2012 with the mission to reimagine the data warehousing space. That's what we wanted to do. We wanted to build a new data warehousing built for the new world. We are located in San Mateo, so very nearby. Right now, we're about 130 employees, roughly half, a bit less than half of engineering, and we keep growing very fast. Two of my co-founders are French, so actually, unlike most Silicon Valley companies, we don't have beer Fridays. We have wine and cheese Thursdays here. And the name Snowflake actually doesn't come from Snowflake schema, but comes from the fact that most of the first employees really love skiing. So that's what we do for fun. We go skiing every year, and yeah, the entire office is, as you can see, themed after skiing. So what is our product? We call it the Snowflake Elastic Data Warehouse, and it's a new kind of a database focused on analytics. It's a multi-tenant, transactional, secure data warehouse, and what's very important and really relevant for this session is it's highly scalable and elastic. It's designed from scratch for the cloud, and what's very important is it's built to provide a true service experience. So it's very easy to use and always operational. Today it runs on Amazon. We already run millions of queries per day, and keep in mind this is not a transactional system; it's an analytical system. So these are not transactional queries; these are analytical queries. So millions per day is actually a lot. We store over multiple petabytes of data, and we have over 100 customers. So a bit of motivation. When we started in 2012, if you look back and kind of read the news, everybody was designing a new SQL on Hadoop system. I counted at some moment over 15 SQL on Hadoop systems announced within a year. And Redshift wasn't around yet, and we were looking around what to do, and instead of looking around, we decided to look up, right? So actually, I didn't really know anything about the cloud, and I started to look into the cloud. And what is this cloud? So actually, on my way to work every day, I pass this logo. It's a shop in San Mateo. I've never been inside, just to clarify, but I dare you, they do something else than we do. So that's not the cloud I'm talking about. This is the cloud I'm talking about. It's kind of interesting because my colleagues presenting before, they talk about building their computers. For me, cloud is my computer. And truly, I believe it's my last computer. You can look at it as a bunch of individual nodes, but for me, it's a new platform. It's a new computing platform. It has its own operating system, and it's some amazing capabilities. And to me, the most amazing capability, one of the most amazing, is elasticity. You can scale different things. You can scale compute. You can scale storage. And what's important about this scalability and elasticity is that it's infinite from the perspective of most of organizations. From the perspective of LinkedIn or Google or Facebook, Amazon maybe isn't infinite. But from the perspective of really probably 98% of companies in the world, you cannot overload Amazon. So you can get all the resources you might reasonably need for yourself whenever you need it. And what's very important is that cloud comes together with SaaS. You're only successful in the cloud, that's what we believe, if you provide software if you provide more than just a bunch of machines. You need to provide a solution which kind of coincides with industries move to the cloud because they want to save costs. So you want to save more than the hardware cost and operations cost on hardware. You also want to save cost of operating software. And for a lot of companies, again, not LinkedIn, not Google, the biggest cost of a lot of infrastructure is people. And people maybe are easy to get, like Hadoop experts maybe are easy to get in Silicon Valley, but if you're somewhere in Nebraska, I dare you, you might have a problem. And they will not be cheap. And the final amazing thing about the cloud for me is that everybody's there, almost everybody. It's a hub where everybody meets. Suddenly, data exchange between companies and communication between companies is not a physical operation, or at least you don't think about it as a physical operation. It's a logical operation. It's with a click of a button, you can share a petabyte of data. And that's just, to me, mind-blowing. So if you remember, 50 years ago, someone said, we think there is, I think that was IBM, we think there's business for 5 computers in the world. And if you look at the cloud as a computer, maybe that's actually what's going to happen. There will be 5 big computers in the world, and the rest will be thin clients like our notebooks and phones. But I'm a database guy, and so when we look at the cloud, can a database be deployed in the cloud? And all database vendors effectively are doing this. You can take the cloud and you can deploy database X on EC2 or any cloud platform you want. But will it work, and will it work well? So for example, will it be as elastic as some other solutions deployed on the cloud? Are these solutions resilient to hardware failures? Because in the cloud, that's one of the bad things about the cloud. These are more frequent than on-premise. And again, software as a service. Are these solutions easier to use? And the answer to all of these is kind of not necessarily. Maybe you can improve things in these dimensions, but it's very hard to achieve all of these benefits for a database. So that's why we wanted to change that. So we looked at the existing architecture of databases, and pretty much it's standard for analytics. Everybody's using shared nothing architecture where tables are horizontally partitioned. And it's a very good architecture for fixed hardware. It works very nicely for kind of standard large-scale star schema workloads. It requires some tuning, how to partition, how to sort, but still it's a very popular architecture, and most successful players in this space use it. So Teradata, Vertica, Netezza, pretty much everybody. But this architecture has this inherent coupling of compute and storage. And this session is about decoupling compute and storage. And it's funny because I think some of my colleagues actually propose coupling them more together. We believe that decoupling, logical decoupling, is very cool. But if you have coupled hardware, like compute and storage, there are some implications of that. So is it elastic? If you need to resize your cluster, you need to redistribute your data. Because when you're resizing compute, you're also resizing storage. These operations traditionally are considered to be rare. So it's OK to spend a day on them, and it's OK to have the system down during that operation. And if you don't need something, you still need to pay for it. My colleagues, again, they talk about pay as you grow. That was a phrase I saw on one slide. And it's great. Pay as you grow is better than over-provision early. But pay as you go is even better because you don't only want to grow, you also go down. You want to go down. And whatever you provision, it will not be correct because there is no balanced system. Every system is in balance, or is balanced only for one of your 27 workloads. And finally, these are homogeneous resources. Well, in the cloud, what we have is not only elasticity of scale, but also elasticity of the kind of resources you can get. So for different workloads, we can choose different resources. So we looked at all of that, and we said, can we build a new database which can take advantage of all these new capabilities of the cloud and deliver it to the customer as a service, which is easy to use and has all these advantages. Quickly about architecture of the system, because I think that's the most relevant aspect to this session. We split our architecture into 3 layers: data, compute, and control plane, or we call cloud services, or the brain. And what's important here is that each of these layers is scalable fully elastically and independently. So for storage, you can scale it from 0 to a petabyte and down, again into 0. The same for compute, and the same for this layer. If we need more resources from the cloud, we can grab it from Amazon in a matter of seconds or minutes. And the same is true for our users. They can grab it from Amazon within seconds or minutes. What does it give us? So maybe first, how does it work? And why did we have to build it as a new software, as a new platform? Because cloud is a new computer, but it's a slightly different computer. The most efficient way, or the most price performance efficient way, is to store data within Amazon is S3. It's a wonderful thing. S3 is amazing. It has some amazing capabilities like scalability, resiliency, availability, durability, all of that stuff. But it has some problems. It's not very fast. It's not very fast from a single node. It is super fast if you access it from 1,000 nodes. So you need to design a system with that in mind. And also, the access model is slightly different. You cannot just fetch a single, change a single byte inside of a file. You have to design your system with kind of read once model. So we had to design our storage and concurrency model with that in mind. And any traditional database system wouldn't just work on that if you wanted to take advantage of that. S3 is great, and we use it for modern data. Actually, what's cool is we use it also for temporary data, like when you have a big intermediate state during your query. What it gives you is that your query will always finish. If you have a query which has an intermediate result somewhere in the pipeline of 100 terabytes, it will finish. It will take a day, but it will finish. And it's amazing because usually people were constrained with this, what do I have on my hard drive? But if you use S3, your hard drive is infinite, effectively. We also can, it's so cheap, we can store all the previous results of the queries in there, and we can query them later, which is kind of new, interesting capability of a system. Of course, S3 isn't great for everything. We use other solutions to store metadata because they need to be accessed and modified, and that's very important, much more frequently. But we have a metadata store which has the same capabilities as S3, meaning it's cross availability zones, highly replicated, highly durable, and all of that. So that was storage. For compute, we do something, storage is completely independent from the compute layer on some level. For compute, we have a bunch of what we call virtual warehouses. These are simply clusters of machines within EC2. And that's where elasticity comes, really mostly. They can be created, destroyed, and resized within seconds or minutes if you're unlucky. You can run multiple of them at the same time. And while they are kind of independent when it comes from the perspective of processing, they have access to the same data. And actually, if you think about it, this is the dream of a database. You want to have access to all the data. Everybody should have access to the same data, but you don't want people to interfere with each other. So, and I think this architecture gives you that. And what's interesting is you can shut down all of your compute resources to 0, and your data stays intact. And that's super important in the cloud because actually in the cloud, storage is relatively much cheaper than compute. Kind of core price of Amazon is $1 per terabyte per day. You can burn, $20 in a few hours very, very easily. So optimizing compute is super important. And with this architecture, we're able to do it. What's important is that these worker nodes are ephemeral. If one of these nodes die, we continue to operate. And since S3 is slower than traditional drive, there is no miracle. We need to be able to process a lot of data fast, so we rely very heavily on local caching. And it works very well. The final top layer is cloud services, and that's effectively everything else. And here we manage things like connectivity, access control, query optimization. Julian will be like, what do you mean query optimization is separate from processing? Transaction manager. It's multi-tenant, that's very important. There is one operational instance of Snowflake in the world. All the users share it. It's highly replicated. State is stored in the key value store I mentioned. And also we provide, it's after all, some people say databases are not sexy, but they are important. So we provide standard interfaces like JDBC, ODBC, and so on. But we also provide a very cool UI, which our users love. And that's very important because if you want to try Snowflake, you have to download literally nothing. You can just go, you can create tables, you can run queries, and it just works. Super important for early adopters. And we spent a lot of time making it easy to use, such that for us, delivering a solution in the cloud is more than just delivering capabilities, but it's also making it simple. So we spend a lot of time on avoiding any features which require users to tune the system. In fact, there is one tuning knob in Snowflake, performance tuning knob, and that is how much you're willing to pay. That's the only thing you control. The rest is kind of automatically managed. So a bit about features. Again, this is a session about decoupling of storage and compute. And we offer what we call multidimensional elasticity, and multidimensional because we talk about 3 dimensions: storage, compute, and concurrency. And they are all possible because thanks to decoupling of storage and compute and ability to scale these things separately. So let's take a look at this a bit. So about storage, I already talked a bit that it's low cost, fully replicated. I think it has 11 nines of availability or durability, and having 6 or 7 nines of availability, infinite capacity, and pay for the space and time that you use. And the time is super important, because if you store 1 petabyte for a day, you will pay $1,000 for Amazon. You'll pay a bit more to us, but if you wanted to build an infrastructure to store a petabyte of data for a week, maybe in your data center, we're talking multiple orders of magnitude more. And that's also super important. S3 is not only elastic and scalable, but it's also shared by everybody. Everybody can have access to the same data at the same time, and we provide full transactional consistency. So you can be loading data into one table, I will be reading from it, everything is transactional. But to take advantage of all of that, you need a processing engine which can work in this context. So what does elastic compute and concurrency give you? If you have this separation, that you have storage here and compute here, and you can scale this independently, you can have one, what we call virtual warehouse, which is running 24/7. It's cheap, it's small, and it's continuously loading data. We actually have customers loading data into Snowflake multiple times per second. And and they pay for this warehouse, and it works. And when they need a large warehouse to process something very computationally intensive, like a weekly report, they can just schedule it, provision it, sorry. It will take them seconds or minutes. They can run the report and then shut it down, and they stop paying for it. So you can kind of scale a single warehouse towards what you need from a perspective of any single query. But what's even more important is that when you have a system which is accessible by hundreds of users, what do you do? So you can have more than one of these things, and you can have these 10 users on one machine and these 20 on another machine or cluster. And they all share the data, but again, super importantly, they do not interfere with each other. Their performance is isolated. And we even have a solution where you can scale how many resources we're getting from Amazon and providing to you based on the concurrency of your workload. So if you have a sudden peak in your performance or in your load, we will automatically get data from Amazon and give it to you if you, of course, let us. And you only pay for what you use. And that allows amazing user scenarios. Here are some kind of anecdotes from actual use cases. Someone told us, if it's cheaper for me to run a query in Snowflake than to walk to a DBA and ask for permission, I'll do it. And actually, it can be cheaper because 10 minutes of a professional's time, especially in Silicon Valley, it's a lot of money. And if a DBA is grumpy, it can be more than 10 minutes. And DBAs can be grumpy. Another thing, I want to run this very, very slow query. And it used to take 16 hours. But because I couldn't afford a big cluster for it. So now I can get a 64-node machine, and I will have it done in 1 hour. And this was one of the most striking to me things in the cloud, that if you have a problem which scales, and a lot of analytical problems in databases, they scale pretty nicely. If a query takes 64 hours on one node and 1 hour on 64 nodes, the user experience is dramatically different, of course. But the price is the same. And that's just mind-blowing. And people, for example, for problems that do scale, like data loading, we've seen people loading, terabytes of data per hour, and they were just like mind-blown. And that's very easy in the cloud. The isolation of compute, independence of processing resources give you this, that you don't need to be afraid that you will run some query which will damage somebody else. And that's very powerful, again, because this is one of the reasons people introduce data marts. There are other reasons, of course, but people say like, you cannot work with me because I don't like your queries. It's gone. You don't need to replicate data. It just works. And this is an actual story. One of our sales guys came back to the office and said, the customer hugged me today because he said that we made his life better because before Snowflake, they were tuning their database, and they were very stressed. It was continuously overloaded every week and so on. But because of all these things, they suddenly could relax. They reduced their smoking. They lost 20 pounds. So I was at a conference a couple of weeks ago where Alan Halevy was telling that he's building a company to make people happy. And I was like, we're already doing that. Felt good. We have a bunch of features which are really, kind of two categories. One is enterprise features, so multi-availability zone deployment. Just what it means is that if a data center dies in Amazon, Snowflake continues to operate. And to all Oracle customers in the room, how much would you pay for that with Oracle, right? And this is standard. It's continuously available. We push new code a few times a week, typically, without any downtime. We are secure. Actually, I think I talked to Per today. People question, will secure data ever go to the cloud? It's already there. There is Gov in the cloud. There is HIPAA data, so health information data in the cloud. And stuff like, no backup. You don't need to do backup. We manage scalability for you. We also do a lot of cool stuff on the SQL front. So actually, my colleagues from Nutanix have some similar stuff, so like time travel and instant cloning, but it's all on the database side. So you can, for example, say, I want to clone my database as it looked 2 days ago and compare the results. More than a table, you can clone or run a query as it was 2 days ago. We optimize for semi-structured storage and processing. A lot of what went into that. And there is extensibility and connectivity to standard tools. So what did we learn? For us, decoupling storage and compute was fundamentally important to our business. Snowflake wouldn't exist without splitting these things. But we had to design the system to take advantage of that. And it really maps very nicely onto the cloud. The result of that is, we opened the data to everybody, so fewer data silos, very different, very new use scenarios. And the user can decide how to scale their costs independently for different layers, and that's very important. One interesting thing is when we introduced semi-structured, so JSON processing, it was a bigger hit than we thought it would be. And turns out that a lot of people, not all of the people, but a lot of people use Hadoop for two things: storage of JSON and converting JSON into CSV, which they load into MySQL. So if you could give them a system that does that better, they replaced Hadoop with that. And this was the most fascinating, probably. I never worked in a SaaS company, so continuous delivery of software to our customers is just fascinating. We can give them bug fixes and new features within hours or days. Just a lot of fun. And people love the node tuning aspect. Of course, it's not just that very simple. For us, software as a service remains a big challenge. We scale very fast, so not only data scales and compute scales, but for example, metadata scales. We have over 1 terabyte of pure metadata on top of petabytes of data. So scaling that is very challenging. Of course, failure handling and everything operational around it is takes a lot of work. Security is a big aspect we need to take care of. And there is a lot of work in things like SQL and providing this solution as a self-service model. So that was it. This was a very short presentation. We have a paper at SIGMOD in a month. So if you're there, you can learn more. And I want to thank my colleague, Philip, who isn't here, but he did most of the slides. I'm taking advantage of him. So that was it. Thank you very much.